Introduction to UML Part 2. In this lecture, I will cover some very popular UML diagrams. Again, I cannot cover all the UML notations in this Visual Paradigm Essential training. This training is mainly for Visual Paradigm user. We are planning to have a UML exclusive for UML training in future. Please stay tuned. First diagram I would like to talk about is the class diagram. Class diagram most likely is the first diagram pop up in your mind when we're talking about UML or object-oriented notations. Class describes the object used in the applications. Class is class, object is object. Object is an instance of a class. We define the definition of the object in class diagram. Inside each class, we have the attributes. Attributes, you can think it as a definition, define the properties of the class, what data you will store in the class. Other than attribute, we also have the operations. Operations is the behavior of the class. So what is a behavior? Behavior is something that you can trigger or talk to the external world. In this case, the writer will have the information login ID, name, age, which is the property, the attribute of the class writer. You cannot access the login, name, age directly. You need to retrieve or modify them through a operations. Say, for example, you have a set login ID, set name, set age, etc. Then we come to a very important notation, the associations. The associations include showing the relationship between different class. It's talking about how to navigate between them. It's connected between one class to the other. In this case, you see the writer will have multiple articles. Otherwise, it's not a writer anyway. And each article in our system is written by only one writer. So we use the relationship to show the navigation between the objects. You see, we also have multiplicity of the relationship. One writer have one or many articles, and each article is only written by exclusively one writer. And generalization and subclass, it represents a kind of relationship between classes. We have article. We have different types of article. Announcement is a kind of article, and post also a kind of articles we have. You see, we can read the class diagram verbally, like the writer have one or many articles, and the article could be a announcement or could be a post. So it's a very human side of the class diagram. Okay, let's go to see how to draw the class diagram in Visual Paradigm. The first step is to create the class diagram. We click the new diagram button, and then you can type class. Then you see the class diagrams. And you can name it. This is a writer. You can put in different locations as we talked about before, and click OK. Then we'll create the class diagram, and then you can start drawing. Like this is a writer, and the writer will have the articles. So we have the association to the article. And in the article, we can add some attributes. You can add the attribute, say the title, and you can put the name at before and stick a colon, and then the type, the string, and you hit enter. Then you can put another attribute summary, and then string. This name colon and the type pattern is defined in UML specifications. And then you can say the body also a string. If you find that's enough, I have enough attribute now, then you can hit escape key to finish the editing. Then we stop here. And now we can change the multiplicity and row name. You can right click and then so to the row A is the writer side, row B is the article side. You can set the multiplicity, say it is a one-to-many, then you will see the one-to-many. And you can edit the row name too. I can edit the row name. Now you see we default in row B. The reason is I right click on the association is close to the row B. Then we can edit the row name, which is article. Then you see the row name, the multiplicity showing here. To add operation, you do the same things. You right click on the class, add operation. Then you can say this is a save, and you can say open. And same as attribute, you can hit escape key anytime if you finish the editing. To draw the generalizations is also easy. You just drag and drop the resource catalog, and then you select generalization, and then you say this is an announcement. And you can draw the other one. I draw the other, and then the generalizations is suppose. I can use the alignment guide to help me to align it better. I put the generalizations in this form. Like that, it's snapped to each other. So it looks great. Before we move on to talk about another diagrams, I would like to introduce to you the package header here. Normally, when you draw the class diagram, we will put it in different package. You can draw the package and group them. Say you put here, then the writer will belong to the package, this package. And how do you know? You can go to the project browser and go to the structure. Then you will see under the package we have the writer class. Okay, you see this is under the package. In the root level we have the different class in the root level. Okay, let's go back. But sometimes when you keep drawing a lot of package, lot of nested level package will be very difficult and inefficient. Then you can use the package header. You say this class is belong to com.vp.knowhow, something like that. Then you see the structure change to the com.vp.knowhow. And we go to the project browser again. Now you see this is under the com.vp know-how, and the article and the package. You see it's automatically put in this nested level instead of putting a lot of nested package in the class diagram. The next diagram I would like to talk about is the sequence diagram. Sequence diagram is very helpful when you doing the interaction modeling and integration modeling. In sequence diagram, you can put the actor. Actor is types of role played by entity, which is most likely the human, that interact with your system. The actor could be a human or could be the third-party systems. In the integrated world, you have a lot of third-party systems to interact with you. And the second element is the lifeline. Lifeline representing an individual participant in the interaction. If you're doing very high-level sequence diagramming, then the lifeline is your system. Like this is the ATM. The message define the communication between lifelines. Lifelines means could be the lifeline and the actor. In this case, you see the user insert the ATM card to the ATM. And we have a return message as a special kind of message, which is showing the response to your actions. You insert the card, and then the ATM will ask for the PIN. And the flow of message is from top to bottom, representing the time begin at the top and then keep interacting until reach the end. The sequence diagram timing is from top to bottom. Please be reminded. Let's see how to draw a sequence diagram. Okay, we knew the sequence diagram here. Sequence diagram. I just name it as default. Then I can draw the lifeline. I can use the toolbar, or I can double click, and then I select the lifeline, which is a user. The actor is a user, and then I can use the resource catalog to draw. This is a kind of the lifeline, or if you like a duration message. Duration message means you need to take certain time to send to the others. It's used to represent some telecommunications. You can create, etc. I just use the lifeline, and then this is an ATM, and then it's insert ATM card. I just give more space. If you want to represent the return message, you can click the little resource to create a return message. This asks for PIN, and you can continue these steps to draw the message to the ATM. Say this is a message, and then I just enter PIN, and you can keep drawing from top to bottom. If you like to incorporate more parties, you just drag and drop to the others, then you have the other parties including to the sequence diagram. Then we move on to talk about the activity diagram. Activity diagram is very similar to the business process, but more system oriented. First of all, the activity diagram has the initial node. The initial node is control the start of the activity. You can put more than one initial node, but if you put more than one initial node, please make sure you state when they will be triggered. Then the second shape you're likely to see is the action. Action represents the single steps within the activity. You click the create, enter the detail, click the save. Between the action and the initial node is control flow. It's an edge that to link the start of the activity node and to the next activity node. It's showing when the first action is completed, it will go to the next action. And finally, you will have the final node. Let's see how to draw the activity diagram. Okay, we create activity diagram now. Just name it as default. Then we can put the initial node. And then you can draw the action. You can draw the action and say this is a click create. Let's have some spelling mistake. And then I can go to the next actions, which is to enter detail. And then I continue to the click save. Things like that. And then finally it is the end, which the final node. So easy. By the way, we suggest to draw the activity diagram in vertical presentations. Most likely we draw the business process in the horizontal one, the activity diagram in the vertical one. It's not a kind of rule or practice. It's just easy to recognize. You're talking about the activity or the business process. And move on to the state machine diagram. The state machine diagram is very similar to the activity diagram, but they split from the UML tool. The state machine diagram have the initial state, which is represent the beginning of the state machines, and you put all the possible and critical state in the state diagram. It's something like we have init, we have pay, or close to. This is a kind of the order status, this order state, and cancel. And then you put the transition to the state machine diagram representing the possible transition between state. For example, we starting from init, and after init we can go to cancel directly, or it is a pay. But you can't go to init can't go to close. You need to go through certain, either go to pay or cancel. This is a kind of possible stage to make sure the implementations is correspond to the design. And the final stage shows the end of the state machine. Similarly, to draw the state diagram, just click the new diagram and type state machine diagram and click next to create it. Then you see the initial state created, and then you can create the state, say this is the init, and then you continue to create pay, and then you can say this is a cancel, things like that, and then you draw this is closed, and finally it reached to the final stage, and then you can connect to the final stage. Then we move on to the final diagrams. I would like to talk about the deployment diagram. In deployment diagram, we have a node. Node is a computational resources. You can say it's a server or computing devices, which we can run some program, run some artifacts that execute on it. And inside the node, we will put the artifact. Artifact is a kind of software or a kind of process that you can deploy to the node. And associations, it shows the exchange signal between certain nodes. Not all the nodes need to connect to each other, and association define who can talk to which other node. Let's take a look on the deployment diagram. We create the deployment diagram now, and we draw the node. You can name it, this is a web server, and you can resize it bigger to accommodate the artifacts. You can put the artifacts, which is the website, and the web server will talk to the, say, the database, and you can name this is DB1. DB1 is the name of your database, and you can define the stereotype. Say, I want to define my own stereotype. I add a stereotype called database for my company. Then I click OK and assign it. Then this is a kind of database. And you want to represent the web server also connect to DB2, which is maybe the replicating database. Then it shows both of them is the database. It hosts the database we have. And you can continue this drawing to show the physical deployment architecture of your system. Let's summarize what we talk about in this lecture. We cover some typical UML notations, including the class diagram to represent the object relationship, sequence diagrams, activity diagrams, state machine diagrams, deployment diagrams.